Okay, number 9 is also ready for elimination because you see positive 4y and negative 4y. When you add in the equation number 1 plus equation number 2 by column, we have then x, 1x and 2x, 3x. When you add in the column of the y, positive 4y minus 4y, 0, cancel out each other. And 32 minus 20 is 12. Divided by 3, because I want to isolate x is 4. And now, in order to get the value of the y, you're using either equation, whatever you want. Of course, I am smart, I'm using the easier. The easier, in my opinion, is number 1. This is 4 plus 4y. Substitution x replaced by 4 for x here, and the equation number 1 equal 32. Now 4y is equal 32 minus 4 is 28. Divided by 4 both sides, y is equal 7. And the solution is 4,7, que is the option C. Good. Okay, and number 10 is easy also. It's ready for elimination because I saw okay, we have negative y and positive y. If you adding equation number 1 plus equation number 2 by column, the column of the x, the column of the y, and the column of the right hand side, 3x plus 2x is 5x. Positive y and negative y cancels out again. And in the right hand side we have 15 divided by 5, both sides, x is 3. Okay, now substitution in either equation. I select because I want the second, I don't know, no special reason. 2 times 3 plus y equal 10. This is 6, 2 times 3 is 6, equal 10, so for y is equal to 10 minus 6, gets 4. Now the point is the point 3, 4, que corresponde with the option A in this case. Good. Okay, equation 11. Equation 11 is weird because equation number 1 and equation number 2 are the similar because one is exactly the same, except one is positive and another is negative. However, what happens when you add in equation number 1 plus equation number 2? It's obvious that positive 9 and negative 9 cancels out, and y, positive 9y and negative 9y cancels out. So in the left hand side we have 0, and in the right hand side we have also 0. 79 minus 79 is 0. This statement is true. That means that we have infinitely many solutions. Infinitely many solutions. Okay, how we write that? It's a set formed by every ordered pair x, y, such that satisfy either equation, whatever, you copy it. Doesn't matter what the equation you want. You copy, for example, the first equation is all the ordered pair is satisfied. The first equation or the second equation, it doesn't matter what you copy. It's the same thing because basically they are dependent equation. And this is the answer que they want, que corresponde all ordered pair along this line, que corresponde with the option C. Okay, number 12, I saw that we have AY and positive AY. Would be fantastic if at least one is negative AY. That's multiplication, the second equation by negative 1, for example. And you copy the first one, x plus AY equal 51. However, when you multiply the second by negative 1, we have 4x positive minus AY equal minus 36. And when you add it by column, we have 5x cancels out the y part. If the x part is 15, because 51 minus 36 is 15 divided by 5, both sides, x equals 3. Well, so in order to get the answer, I take the equation number 1. Is 3 plus ay equal 51. Ay is equal 51 minus 3, que is equal 48, divided by a, both sides, y is 6. And the other pair solution is a 3,6, que corresponde with the option A. Okay, 13. In 13, I propose multiplication equation number 1 by negative 1. Because I need positive 5y and the second is negative. So it's negative 1 multiplied by whole thing, that by the entire equation is minus x plus 5y is equal minus 38. I copy the second, exactly the same. 2x minus 5y equal 41. And you add it by column. This and this, 2x minus x is only 1x. This is cancelled. And this is 41 minus 38 is 3, positive 3. Okay, in order to find the y, I plug it in 3 in the first equation. For example, it's 3 minus 5y equal 38. So for y, minus 5y is equal 38 minus 3, que is 35. Now negative 5y is equal positive 35 divided by negative 5, both sides. Y is negative 7. And the solution is the order pair 3, negative 7, que corresponde with the option A. Okay, 14 is a system of equations that contain coefficients and fractions. You eliminate the fraction always. So, for example, the least common denominator in the first equation is 12. It's a multiplication 3 and 4. When you multiply the entire equation number 1 by 4, 12 divided by 3 is 4x. 12 multiplied by 1/4, okay, it's the same, divided by 4 is 3, minus 3y is equal 12. And this is the new equation number 1, without fraction. Likewise, the least common denominator in the second equation is 6. 6 multiplied by 2 is 12, divided by 3 is 4. Making is 4x. 6 multiplied by 1/2, okay, it's the same, divided by 2 is 3, plus 3y is equal 6 multiplied by 2 is 12. And this is equation number 2 without fraction. Now this equation is ready for elimination, because when you adding this equation and this equation is 8x cancels out this part is equal to 24. Divided by 8, both sides, x equal 3. Okay, for finding the value of the y, I propose using not the horrible in the original equation, no. Use substitution in either equation 1 or 2. I select number 1. This is 4 times 3 minus 3y equal 12. 4 times 3 is 12. Minus 3y is equal 12. Minus 3y is equal 12 minus 12, que is 0, divided by negative 3 both sides, is obvious que y is 0. Solution is 3,0, que corresponde with the option C.